Good day, viewers. You are welcome to today's math class. So, what we are going to be talking about today is SURD. But firstly, the subtopic rational number and irrational number. We all know that rational numbers are numbers which can be expressed in this form A over B, such as 3, we have 5, we have 0.7, we have 0.13. How? Because 3 can be expressed as 3 over 1. That's why it's a rational number. 5 also can be expressed as 5 over 1. 0.7 here can be expressed as 7 over 10. Don't forget, I said irrational numbers are numbers that can be expressed in this form, which is A over B. So now, what are irrational numbers? A number, when expressed as decimal, neither repeat nor end. Irrational numbers are numbers when expressed as decimal, neither repeat nor end. So, example is pi. Don't forget, we can only approximate pi as 3.142 and so on, because it has no end. And also e, which we can approximate it as 2.718 and so on. So also we also have another irrational. We also have others like root 2, which is 1.414 and so on. Also we have root 12, which is approximately 3.464 and so on. There has no end. So irrational numbers are numbers that can only be approximated, which has no end. They have no end. And so we can now agree that SURD are irrational numbers given in this above form. So we can say that SURD is the root of rational numbers. Don't forget 2 is a rational number. So the root of rational number is SURD, or irrational numbers given in this above form. Now we move to the rules. The rules of SURD. Firstly, we are going to solve a question and explain why the rules are like. Firstly, we are going to form the root and the rules out of this. You have a question like this: root 16 times 25. Don't forget, root 16 times 25, if you multiply it, you are going to get root 400. And root of 400 is 20. Yes, this is right. Also, if you solve it in this way, which is root 16 times root 25, you know that you have splitted it and both have their roots. And we said root 16, you splitted it and you solve it separately before you multiply it. And we said root 16 is 4, root 25 is 5. What do we also get? We got 20. Therefore, the root implies that root AB is equal to root A times root B. I hope you understand. This is the first rule. That means if you have a question like this, you can solve it separately and you are still going to get the same answer. You can say that the result is same. The second rule, which is, let's use this number. Let me use this number to explain. We have 36 over 9. So 36 divided by 9 is going to give us 4. Root 4 is equals to 2. Also, if you solve it this way as root 36 over root 9. So root 36 is equals to 6. Root 9 is equals to 3. 6 divided by 3 is 2. You can see that the result is same. Therefore, this implies this. So that's why we derive this rule as root A over B is equals to root A over root B. This is also another rule of SURD. So number 3, we have a question like this: root 4 plus 9. So if you add it together, we have root 13. And don't forget, root 13 using calculator is going to give us 3.60555 and so on. Also, you solve it this way by splitting it. Root 4 plus root 9. Root 4 is going to give us 2. Root 9 is going to give us 3. If we add it together, we have 4. We have 5, sorry. So you can see that this implies that these are not equal. Therefore, this is where we derive the rules. In general, we say A plus B is not equals to. This means is not equals to root A plus root B. Let's move to another rule again. We have root 25 minus 9. We say if you subtract it, we have 16. Root of 16 is 4. Okay, let's split it again. We have root 25 minus root 9. Root 25 is going to give us 5. Root 9 is going to give us 3. 5 minus 3 is going to give us 2. You can see that it's not giving us the same results. Therefore, root A minus B is not equals to root A minus root B. So, having done that, we are moving to the basic form in SURD. So now, to simplify SURD, a SURD means to be expressed the number under the root sign as a product of two factors, where one of them is a perfect square. So you are given this question, root 108. You are asked to simplify this. Example 1. So before you can simplify this, you have to express it as a product of two factors, whereby one of the factor is the perfect square. Example of perfect square are 4, 9, 16, because you can easily get the root, and so on. So which perfect square can we multiply with a number that is going to give us 108? I think of 36. We have 36 times 3. 36 times 3 is equals to 108. And don't forget, we can easily find the root of 36, implying the rule of multiplication. We said we can split this as root 36 times root 3. And root of 36 is what? Sorry guys, I hope you are seeing it now. Root of 36 is 4. Is 6, sorry, times root 3. Therefore, our answer here is 6 root 3. Let's solve another question again. Another example. We have 288. So now, which perfect square can you multiply with a number that is going to give us 288? So you have root 9 times 16 times 2. 9 times 16 times 2 is going to give us 288. And don't forget the multiplication rule. We can split this and say that root 9 times root 16 times root 2. Don't forget, 9 and 16 are perfect square, which you can easily find the root. Therefore, we can say that root 9, 3 multiplied by root 16, which is 4, multiplied by root 2. This is an irrational number. So we can solve it. So what we are going to get is 4 times 3, which is 12. 12 root 2. You can see that we have simplified it to its basic form. And don't forget this number. Let's solve an example again. Third one, we have root 54. Root 54 can be expressed as 9. 54 can be expressed as 9 times 6, and 9 is a perfect square, which you can easily find the root. Root of 9 is 3, so we have 3 root 6. That's all. And don't forget, you can easily change this, you can easily transform this basic form to its normal form back. The transformation which reduces a SURD to its basic form can easily be transformed or can easily be reversed. You can easily reverse this. To reverse this, we have 3 root 16. This number outside, you are going to square it. If you square it, don't forget the square of this number is the root is going to give us 3 back. So we can say that 3 raised to power 2, which is 9. Therefore, we have root 9 times root 16. Sorry, root 6 rather. This is what we want to reverse. So root 9 times root 6. And don't forget the rule of multiplication, which I just taught. You can bring it together and multiply it. 9 times 6, which is equal to root 54. Don't forget root 9 is going to give us 3. That's as it's very simple to reverse. Here now, we want to reverse this. We have 12 root 2. How can we express this as a root number? You can say that root 144, because root of 144 is going to give us 12 back. Root 144 multiplied by root 2 is equal to root 144 times 2 is equal to root 288, and so on. So we'll move to the addition and subtraction of SURDs. So now, in SURD or root, you can add or subtract like SURD in same manner as like times in algebraic letters. Like SURD are SURD that have the same number under the square root sign. For instance, now you have root 3 plus root 3. Don't forget, you can easily add or subtract like times, and these like times are numbers are SURD which has the same numbers under its square root. You can say it has the same number under its square root. You can easily add it. Don't forget, you can add this. If you add this, you have 2 root 3, because there is a 1 in front of it. 1 times root 3 is going to give us root 3. So if you add these two together, it's going to give us 2 root 3. Also, you can say question like this, which is 4 root 11 minus 4 root 11. You can say that it's a like term. Therefore, we say that 2 root 11. You can say that 4 minus 2 into bracket root 11, which is equals to 2 root 11. Also, question like this, we have root 18 plus root 8. We can express this to its basic form, which is root 9 times 2. And we can also express this, don't forget, root 2 times 4. Don't forget, root of 9, 3 times root 2. We have 3 root 2. We have solved this here. I hope you haven't forgotten. And here we have 2 root 2. Since it has the same number in its square root, therefore we can add it. They are like terms. 3 plus 2, we have 5. 5 root 2. The same way for minus sign. You solve everything the same way. So let's solve this question. Now we have root 48 plus 4 root 90 minus 2 root 40 plus root 27. So you can express this. Don't forget to express this. You will look for two factors whereby one of it must be a perfect square. We have 16 times 3 plus 4 here. We have 4 outside, don't forget. And 90 can be expressed as 9 times 10. Here we have minus 2 outside. 40 can be expressed as 4 times 10. And we have here, you can express this as 9 times 3. Root of 16 is 4. So we have 4 root 3 plus
Like
root
and
of 9
subscribe.
is 3. And don't forget, we have 4 outside already. Therefore, 4 times 3, which is 12 root 10. Here, root of 4 is 2. And we have 2 outside here. 2 times 2, which is 4. And here, root of 9 is 3 plus 3 root 3. So, add the like terms and subtract the like terms. These are like terms, therefore you add it together. 4 plus 3, which is 7 root 3, and here 12 minus 4 root 10, which is 8 root 10. That's all for addition and subtraction. So guys, simplifying SURD containing brackets. We are moving to this now before we move to conjugate. To simplify SURD containing brackets, what you need to do is to just let's expand. Firstly, a times x, we have ax. A times y, we have plus ay. Don't forget, always notice the sign. B times s, we have bx plus bx. B times y, we have plus by. You can see this times this times this times this times this also. That's all. This is very simple. A times x, ax, a times y, ay. So let's solve the question now. We have, for instance, we have open bracket 3 root 3 plus root 5. Also, we have times root 3 plus 3 root 5. To simplify this, we are going to simplify it in this form. We have root 3 times, so we have root 3 times 2 root 3 plus root 3 times 3 root 5. Also, we have 5 times root 5 times 2 root 3. Also, we have root 5 times 3 root 5. Don't forget, we are simplifying in this form. This is the form that we are following. So now, let's simplify this. We have been taught this. To simplify this, we have 2. And root 3 times root 3 is going to give us root 3 square. Don't forget, root 3 times root 3 is going to give us root 3 square. Plus, here now, you can see that it's not a like times. Here it's a like times, that's why we relate it to power of 2. But here now it's not a like times, therefore you just multiply it using the rule, multiplication rule. Don't forget, we have 3 root 3 times 5. Plus here we have 2 root 3 times 5. And here we have, here is the like times, so if you multiply it, it will be raised to power of 2. Raised to power of 2. So now, root cancel power, 3 times 2, 6, plus, here we have 3 root 15, the other side we have 2 root 15, plus, root cancel power, we have 3 times 5, which is 15. Here now, it has a like terms, since it's the same number under the root, you can easily add. So we have 6 plus 15 is 21, root 3 root 15 plus 2 root 15 is 5 root 15. Therefore, this is our answer. Hey guys, sorry, are you seeing it now? So this is our answer. This is to simplify SURD containing bracket. So let's move to conjugate. So we said two SURD are conjugate if their product give rise to a rational number. And don't forget, rational numbers are number like 2, 4, which can be expressed as which can be expressed in this form A over B. And so if we express this in that form, we have 2 over 1, 4 over 1. So we have taught this earlier. For instance now, and don't forget, we are going to be needing our knowledge on difference of two square. For instance now, we have open bracket A plus B, also A minus B. We said this is the difference of two square, which is equals to A square minus B square. A square minus B square is going to give us this. Don't forget the product formula. And we used to call this difference of two square. Also, in similar way, we can. So looking at it in this way, we said this is the difference of two square. So in similar terms, we can say that root A plus root B into bracket, open bracket, root A minus root B is equal to root A square minus root B square. So root A square, root cancel the power, root cancel the square, we have A, and here we have minus B. Therefore, we said conjugate. When you multiply it together, it's going to give us an irrational number. You can say this and it's going to give us a rational number. This is a rational number. See what it gives us.
Don't forget to subscribe.
That eliminate the SURD. That eliminate the irrational numbers. So we can say that the conjugate of root A plus root B is root A minus root B, and also in similar term, we can say that the conjugate of root A minus root B is root A plus root B. Therefore, what only change is the sign. Note that. So let's solve the question. So if we express this in this form, this is a conjugate. The conjugate of this is this. So let's solve it. Let's simplify it in this form. We say that root 3 square minus 4 square. Don't forget in this form. So root cancel the power here, we have 3, and 4 square is what? 16. 3 minus 16, we have minus 13. This is our answer. Very, very simple. So before we solve a bigger question and more complex question, let's talk about irrational numbers. I mean rationalizing the denominator. For instance now, you have a question like this, root 3 over 2. Don't forget we are talking about rationalization of denominators. This is what the question should look like. This is what our answer or the numbers should really look like. But sometimes the question may look like this, 3 root 2, and therefore we will need to rationalize it. Why most people do rationalize is that to make the work easier, it's better you divide with an odd number or a whole number than you should divide with a SURD. Now this is an irrational number. You divide with SURD. So we will need to rationalize it. And to rationalize this question like this, you multiply the denominator and the numerator by the denominator. The denominator here is root 2. So multiply the numerator by root 2 and denominator by root 2. So we have 3 times root 2, 3 root 2. Here we have root 2 times root 2. Don't forget, is equal to root 2 square, root cancel power. So we have 3 root 2, and we have to see that we have gotten our whole number. Therefore, that's why we rationalize. Therefore, if you have question like this, in this form, so in general, let's write down the rule. In general, A over root B, you are going to express it as A over root B times root B over root B is equal to A root B over B. Know this is the general form. This is also one of the rules. Further rationalization. We are going to consider these two questions now. Don't forget we have learned conjugate. So with our knowledge on how to rationalize and conjugate, let's solve this. We have 2 plus root 2 over 2 root 2 minus root 4. Don't forget the conjugate of 2 root 2 minus 4 is 2 root 2 plus 4. Don't forget the conjugate. That's the first thing. And the second thing is that we are going to rationalize because we have a root at the denominator. Don't forget, we talked about this earlier in this place. When you have a root at the denominator, you are going to rationalize by multiplying the denominator by the numerator and denominator. So that's what we are going to be doing here. Now we have multiplied by this, which is also don't forget the conjugate. 2 root 2 plus 4. That's all what you need to solve this question. So now don't forget the simplifying of brackets we talked about, that this times this times this times this times this. That's what we are going to do. And don't forget here the conjugate. You have plus sign, minus sign, difference of 2 square. So here now, if we simplify by using opening the bracket, we have root 4 4 root 2 plus 8 plus 2 times 2 plus 4 root 2. Try it. We are going to get the same answer. And here now, using difference of 2 square, need to write it out. So if you add this together, all what we are going to get here now is 12 plus 8 root 2. And here now, if you simplify this, you should be having, so this is going to give us 8 and this is going to give us 16. 8 minus 16, which is minus 8. Therefore, they said we should leave our answer in this form: m plus n root p. And if we divide this, we have minus 12 divided by 8 minus 8 divided by 8 root 2. So we can say that the answer here is 2 can go, 4 can go here, which will have minus outside. Let's put the minus outside the bracket. 4 here, 4 here, we have 3 over 2. And this divide each other, we have minus root 2. Sorry, plus root 2, because minus, if you use and open this bracket, we are going to get negative. Therefore, the value for m here is 3 over 2, and the value for minus 3 over 2, sorry, and the value for 2 and for n is 1. Also, the value for p is equals to 2. 2 is 1 inside the root. And also simplifying this in
To
the
watch
same way,
more,
we
subscribe.
have 2 root 5 plus root 3. Don't forget, we are going to rationalize, multiply the numerator and the denominator by the conjugate of 3 root 5 minus root 3. The conjugate of this is going to give us root 5 plus root 3. Don't forget the sign will change. And also root 5 plus root 3. If you multiply it, simplify this times this times this times this times this, what we are going to get is 30 plus 5 root 15 plus 3. And if you look for the difference of 2 square of the denominator, which is root 3 square, we got 5. Here we have 33 plus 5 root 15 over here. Now we got 45 minus 3. Don't forget, this is going to give us 45, this is going to give us 3. And 45 minus 3 is 42. So leaving your answer in this form, we have 33 over 42 plus 5 over 42 root 15. This is the value for m, this is the value for n, and this is the value for p. So you have a question like this. Here now we are giving this in square and we are asked to we have to solve this SURD. Is to don't forget this is in square and the meaning of this square is that this times this. Don't forget this times this thing this question times itself is going to give us the square of it. So we have first thing is to solve for the square, which is 2 root 2 minus root 3 over 2 root 2 plus root 3. The square, which is 2 root 2 minus root 3, we are going to multiply each other back. 2 root 2 plus root 3. So don't forget simplifying in bracket. Don't forget, if you are simplifying question like this, you are simplifying it in this form. Question in this form, you are simplifying like this: a times a square, a times b, ab minus b times a minus ab minus b times minus b, which is minus b square. Therefore, you are simplifying it in this form: a square minus 2ab minus b square. So that means to simplify this, if you multiply it, what I mean is by multiplication. Don't forget, I've written this before for you guys, where I wrote simplify question in bracket forms. So that's what we are going to be using here now. If we simplify the two, what we have is 8 minus root 4 root 6 plus 3. Don't forget, this times this times this times this times this, add it together. And also for the denominator, this times this times this times this times this, and add it together. For the denominator, we have 8 plus root 6 plus 3. So we have 11 plus 4 root 6 over, minus 4 root 6 over 11 plus 4 root 6. Now we can now rationalize. Here we first eliminate the square, because don't forget they told us in the question that this thing is raised to the power of 2. So we'll multiply it by itself again. So we'll rationalize the denominator by the conjugate of the denominator. So we have 11 minus 4 root 6 over 11 plus 4 root 6 times 11 minus 4 root 6 divided by 11 minus 4 root 6. So if we multiply this, we have, for the denominator, don't forget the denominator is a difference of 2 square. So we have 11 square minus 4 root 6 square. And for the numerator, if you express that in this form, don't forget, this times this times this, what I said the other time, expansion, you are going to have 121 minus 88 root 6 plus 96. So we have 217 minus 88 root 6 over 25. Divide 2 by 25, we have 8.68 minus 3.52 root 6. They said we should leave our answer in this form. Don't forget what the question said. Therefore, A is equals to 8.68 and B is equals to minus 3.52. C, which is equals to 6. So the last question for this class is this. You can simplify this in two ways. Therefore, you can first rationalize this and add it together, or you should say that these are the LCM, then solve the fraction, later you rationalize and get your answer. So let's rationalize this separately and get our answer. We have 2 over 3 minus 2. To rationalize this, we have minus times 3 plus root 2 over 3 plus root 2. Don't forget the conjugate of this, which is the opposite sign, and multiply the numerator and denominator by it. And also for this side, we have over 3 plus root 2. The conjugate, you might multiply it, we have minus 3 minus root 2, that is 3 minus root 2. So if you solve this, you have 6 plus 2 root 2 divided by, don't forget this is the difference of 2 square. 3 raised to power 2, we have 9. Root 2 raised to power 2, we have 2. 9 minus 2, we have 7. For this, if you multiply this, we have 3 minus root 2. This is straightforward. And here, difference of 2 square, you have 9. It's similar to this. So you have 7, sorry. It's similar to this. Therefore, solve the fraction. The fraction, the LCM here is 7. 7 is 7, 1. 1 times this, 6 plus 2 root 2. 7 7 here, 1. 1 times 3 minus root 2. We have plus 3 minus root 2. And if you add this together, you can easily add this together and you add this together because they are like terms. Here, adding the whole number, we have 9 minus, no, 9 plus open bracket 2 minus 1 root 2. Don't forget that's 2 and this have an invisible one in front. So if you subtract it, our answer here is 9 plus root 2 over 7. Guys, please subscribe, like and share. Please share this video and drop a heart. Love you all.